I've now got this circle over here. By the way, this is called circle O. This is literally how you would write it symbolically. Instead of writing up, now if you wanted to, you could literally write the word circle O, or you could abbreviate it just with the circle symbol and then the letter O, because remember, O is going to be the center of that circle. There's circle O. It says, what are the minor arcs of circle O? I'm going to give you one. Did you guys know that AD arc, this is a minor arc? Can someone please give me a different minor arc other than AD? CE is also a minor arc. Thank you. CE is a minor arc. Can anyone else give me a different minor arc? Does anyone see any other minor arcs? Which one? ED. ED is a minor arc. It is, correct. Oops, he said ED. By the way, ED is the same thing as DE. Let me write it this way. These are both the same, just to let you guys know. The order in which you write the letters doesn't really matter too much when it's a minor arc. If you switch them around, this is the same arc. It's just, he said ED and I wrote it as DE. Same thing. Can anyone see any other minor arcs? There's one more. What's the remaining minor arc? Ishmael says AC. It is AC. That is correct. Thank you, Ishmael. Very good. You are engaged. I appreciate it. Does everyone have kind of a good idea of what a minor arc is? Okay, great. Semicircle. I'm not even going to tell you this one. Can anyone tell me what a semicircle is on this particular circle? Which one is a semicircle? Tomas. DC. Now, here's the thing. For this one here, I'm going to write it this way. Does anybody know why I use 3 letters here? Could I have just written DC, like Tomas said? Yeah. Why not? Say that again. Right, you have to have it, but my question is why? Why do you have to have that middle letter? Hey guys, if I wrote just DC, why might that be a problem if I just write DC as a semicircle? Right, because I skipped E. Here, let me show you, okay? You see this arc right here? That's the semicircle we're talking about, correct? Let me show you a different one. Do you see this one right here? Did you see someone else calling that one DC too? You understand what I'm saying? You could get confused on, if I just said DC, if I just said this, it'd be like, is it the red one or the blue one, right? So it would be confusing, all right? So that's why you have to have 3 letters for a semicircle, and actually you have to have 3 letters for a major arc, okay? Does that make sense? By the way, AD, this guy up here, if I said the minor arc AD, is there any way to get that confused? No, AD is just AD, right? There's no way to get that mixed up, right? Can someone give me a different semicircle besides DEC? Yeah, Alex. ACE. ACE. So let's see here. Let's go with ACE. All right, let's see what that one is. AC. Okay, good. That'll work. Can I get one more semicircle that has not been mentioned? There's 2 more, but can anyone give me one more? We've got, let me do this one in the darker blue. This was the first one here. This is the one that Tomas gave us, this one. The lighter blue, that's the one that Alex gave us. Can anyone give me one more semicircle? Ishmael says DAC. Yes, Ishmael, that will work. Thank you, sir. DAC, that's this one right here. So I'll call it DAC. And by the way, there is one more semicircle, but we'll just leave that last one off, okay? So there's 3 of them. There's one more. I'll leave that one up to you. Last thing, I'm going to give you a major arc. Let's do this in black. Here is a major arc. D-A-E. Arc D-A-E is a major arc. D-A-E goes all the way to here. That is more than a semicircle. That's why it's called a major arc. That is why it's called a major arc. Can someone give me another example of a major arc besides DAC? And actually, while you're thinking about that, let me tell you one other thing. Guess what's true about this arc? Oops, screw that up. Does anybody notice anything between those 2 major arcs I just listed there? There's arc DAE and arc DCE. What do you notice about those 2 arcs? Let me erase this a little bit up here. I'm getting there's a lot of stuff going on up here. Look at arc DAE and arc DCE. What do you notice about those 2 arcs? They're the same arc. So they're the same arc. They're not different. So here's the thing. The way you name an arc, there might be more than one way to name it. Okay? These are correct namings for this arc right here. In fact, I'll do it in green. This one right here. We're talking about this arc right here. DAE, which is the same thing as DCE, those are that major arc. Okay, did anybody come up with a different major arc besides that one? What's another major arc? Major arc has to be more than a semicircle. More than a semicircle.
ACD.
ACD, that will work, thank you. ACD is also ACD, that's this guy. That is a major arc. And there are more. Let's not worry about all of them. So we have what we call minor arcs. Those are the small ones. They're less than 100, they're less than a semicircle. We have semicircles. Those are exactly halfway around the circle. And then we have major arcs. Those are more than a semicircle. Okay? Good job, guys. Thank you for participating. All right, we're going to play a Kahoot now. Let's go ahead and keep that. You know what, now that I think about it, I'm not sure I pulled that up. Get that going. Okay, guys, we're going to play a Kahoot here just to practice some of these things we just talked about. Now, guys, I'm going to forewarn you, there might be some questions on here about some stuff that I haven't even quite talked about yet, so we'll see how you did. I'm trying to build up your vocabulary here before we start doing problems involving math. Okay, while you're joining, I want to mention one final thing here before we get started on this game, just to make sure we're okay. So we just spent time talking about these minor arcs, these major arcs, and semi. You might have heard me say numbers. And I was kind of screwing up here because it turns out that the way we measure this arc AD is we measure that central angle. So if that central angle was, let's say, 50 degrees, we would say that the measure of the arc was 50 degrees. So you kind of heard me say that, so I wanted to clarify that. We'll get to that more in a second, but I just want to throw that out. Okay, I'm still waiting on a couple of people to join. When you get at least 10 people to play, that'd be great. You should have a total of, let's see here, 4, more. Yeah, there should be one more. I need one more. Okay, we're going to go ahead and start. So if you want to play, you need to join very quickly. Naming arcs. Name arc DE. Is it a major arc? Is it a minor arc? Or is it a semicircle? DE. Four seconds. Okay. This is kind of an easy one because since it said DE, you don't even have to look at it. If it's only got two letters, guess what it has to be? It has to be a minor arc. So that's kind of a quick way to know the answer without even having to look at the picture. Remember, a minor arc has to be less than a semicircle, so it has to be less than 180. Less than 180. Grant, you're in first place. Arc EBA. EBA. Is that a major arc, a minor arc, or a semicircle? Okay, wow. So a lot of you said that you thought that was a semicircle. So I think it was EBA, right? So you start from E, and then you go all the way around to B, and then you go to A. Is that more or less than half of a circle? Well, that's more than half of a circle, right? That's actually more than 3/4 of a circle. So that is a major arc. That is a major arc. Ishmael, you are in first place. Grant, you are in second now. Alec, you are in third. Easy one, right? Minor arc, major arc, semicircle. Which one is it? Okay. Guys, I'm not sure how you're missing that. If it's two letters, what does it have to be? It has to be a minor arc. Has to be a minor arc. If they're only giving you two letters, it's got to be a minor arc. So that's the answer. Ishmael, you are on fire. Grant, you are in second. Alex, you are in third. Let's see if we got it figured out now. There we go. Arc DC. All right, I think you guys got it figured out now. Good, everyone got that one right. Ishmael, you're still in the lead. Alex, you are in second. Name arc ECB. ECB. Semicircle. ECB is exactly half of a circle, so we call that a semicircle. Ishmael, you are on fire. You got 5 in a row. Alex, you're in second. Arc ACB. ACB. Major, minor, semicircle. good. That's a major arc. It's more than a semicircle. Ishmael, you are still on fire. Arc BAE. BAE. Okay, most of you got that one right. That's a semicircle, halfway around. Ishmael, you are still on fire. Alex, you're still in second. DCB. 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 Okay. This one's kind of a trick one. DCB. DCB. Is that more or less than half of a circle? Less than half. So it's a minor arc. You might say, wait a minute, Mr. Allen, you're being tricky there. That's not right. Minor arcs are only supposed to have 2 letters. You can do 3 letters. 2 is sufficient. But you can do, if you go from D, C, B, is that less than half a circle? Yes, it is. And by the way, you could have just called that arc DB. That would have been sufficient. So this one is actually a minor arc. Alex is now on fire. 6 in a row, Alex. You're in first place. Ishmael, you were in second. 2 more. What would you call the red minor arc? This one you could use. Oh wow, no one got that one right. Guys, you could either call it arc AB, or you could call it arc BA. Either way is correct. So either of these would have been correct. Nobody got that one. I'm surprised. Minor arc. Alex? Or did you get that one, Alex? Oh, I thought I did.
The blue one. Blue and green are both correct answers.
Oh, I thought it said no one got that one right. I'm sorry, I must have misread that. Okay, last problem. What would you call the green major arc? All right, almost everyone got that one right. It is arc ACB. Let's go ahead and see who our winners are. Third place, Jake. Congratulations, Jake. Ishmael, you are in second place, and our winner is Alex. Good job, Alex. Okay. Now, guys, I'll be honest with you. When I was thinking about doing this activity, I thought, you know what? I don't know that I need to do that. That just seems like it's not too difficult. I think kids will figure it. Yeah, I'm glad we did that because it was clear that some of you weren't quite sure what a minor arc or a major arc was, and I think you guys have a much better understanding of that now. So good job, guys. Thanks for playing. All right, so we're going to now get into doing some math. So here we go, and we're doing good on time here. I still have about 15 minutes left before I have to cut off here. So here's that thing I was saying right before we went to that game. You heard me a second ago mention numbers. So this arc right here, this is arc RT. We say that RT's measure is 50. Basically what we're saying is the central angle there for that arc is 50 degrees. That's what we're saying. That's what it means. The measure of a minor arc is equal to the measure of its corresponding central angle. The measure of a major arc is the measure of the related minor arc subtracted from 360. So for example, if arc RT is 50, guess what the measure of arc RQT is? Well, you would just do 360 and then you would minus the 50, so then that would give you 310. All right? So that's the idea. Okay? So this minor arc measured 50. This major arc is 310 degrees. So arc addition postulate, this is very similar to what we did with segment addition postulate. The measure of this major arc right here, the major arc ABC, is simply the sum of the minor arcs AB plus the other minor arc BC. That kind of makes sense, doesn't it? That kind of makes sense. So let's look at an example of that. So here now we're going to start dealing with numbers, all right? What is the measure of arc BC? Can anybody just look at that and tell me what's the measure of arc BC? Alex? 32. Guys, it's just 32 degrees. That's the answer. You just look at this angle right here. You see that this angle is 32 degrees, so that means that that arc measure is 32 degrees. I mean, this isn't rocket science, right? That's pretty intuitive. Okay, I'm going to someone in the virtual classroom now. Someone out there. What is the measure of arc BD? BD. Someone out there in virtual land. I know you got this one. Someone out there, though, that hasn't maybe spoken today. It'd be really nice. Ishmael, you're out, buddy. You've helped out a lot today. I'm not going to ask you to do anything else right now. Can someone else that's on the virtual side of things help us out here? What is the measure of arc BD? Caleb, Jacob, Riley, Liliana, Andy. Can anyone tell me what the measure of arc BD is? You can type it in the chat if you're shy. Okay. Liliana said 92. Liliana, you are absolutely correct. It is 92. Thank you, Liliana. It is 92 degrees. You just take this 60, and then you'll add this 32, and you will get 92. Now notice in the picture, and this is important for you guys to notice, in this picture, I have that this angle is 32, but then up here I wrote that the arc was 60. That implies that that central angle is also 60. All right, I'm going to do the next one. C, what is the measure of arc A, B, C? Well, guess what that is? That's a semicircle, and that's half of a circle, so it has to be half of a circle, so it's 108. I think that's kind of intuitive. I don't know. Do you guys think that's intuitive? A full circle is 360, right? So what's half of a circle? 180. All right, last one. Can anyone tell me what the measure of arc AB is? Arc AB. Alex.
148 degrees.
148 degrees. Alex, how'd you get that 148 degrees?
180 minus.
You got it. Just do 180 minus this 32. So what we got here is the same idea of that segment addition, but in this case we're going to call it arc addition. We know that this whole arc is 180. We know that this piece of the arc is 32. So if I want just this piece here, I just need to subtract those two guys, and I'll get 148. Does that make sense? I think this is kind of intuitive, but if you have questions, please let me know. Jacob, I see you got an answer there too. Thank you, sir, very much. You were correct, 148. So that was example 5. Can we move on? Maybe I'll wait just a second. All right, now we're going to talk about something you guys probably already know. So if you already know this, I apologize, but I just need to make sure that you know this. It's something called circumference. I'm sure you know circumference, but just in case you've forgotten, circumference is just basically the distance around a circle. So if we were going to take a path all the way around this circle, we would call that its circumference. The formula for circumference, there's 2 of them. Circumference is equal to pi times the diameter, or the way we normally would write that is C equals pi times D. The other formula, this one right here, the circumference is 2 times pi times the radius. And I think you guys are familiar with that. I hope so. Yes.
2 pi r squared is.
That's the area.
Right?
Yeah, that's the area. Just, so Alex is bringing up a good point. Let me write that. So I'm going to put note. We are not talking about area today. We'll talk about it later. So that's why I'm not mentioning, A equals pi r squared. That's for a different lesson, but you're absolutely right. Okay? Today we're talking about the circumference, which is just the distance around the circle. So determine the total distance around the track. Now, when I say the total distance around the track, pretend that you're a runner and you are going to run all the way around. In fact, I think I'm going the wrong direction. And those of you guys that are involved in track, you're probably like, Mr. Allen, that's not the direction we run. I think they run the other way. Is that right? Do you have any track runners in here? I don't know if any of you guys are track runners. I think they go the other way. I think they normally start here, and then I think they go this way. I think that's the way. So my question is what's that distance? What's the distance? Well, let's start with the easy part. Let's do the straight parts. If this is 60 degrees up here, or 60 feet right here, what's this distance down here? Got to be 60 feet as well, because this is what we call a rectangle. And in a rectangle, we know that the opposite sides are congruent. Now, what do we have left? Well, what we have left is a circle. So now we just need to get the circumference. So the circumference is equal to pi times the diameter. In other words, it's going to be pi times, and what is the diameter of this circle? Well, it's the distance across the circle, which is 28. Now let's go ahead and use our calculators. Now, remember I said you want your calculators today? Would you please take 28 times pi? By the way, you have a pi button on your calculator. Please use that button. It also helps if you turn your calculator on, Mr. Allen. I got 87.96. Anybody else get 87.96? Okay, thanks, Alex. So what is our final answer then? What would the final answer be? Well, we have to add up this number, and this number. So the total distance around is going to be 60 plus 60 plus 87.96, and I get that to be 207.96. So basically almost 208 feet around is what this track would be. And guys, I don't even know if that's that's actually probably a very small track. I kind of just made these numbers up. So 60 feet's not very far away to run. What is that? 60 feet, I guess. 60 feet. So we got 208 feet to run around this track. A mile is what, 5,280. So not anywhere close to that. I don't know if that's legal or not, if that's a legal track size. Comments or questions on that one? So again, what we did is I took this 60 plus this 60, but then I had to get that whole circle circumference, which is pi times diameter. All right, last thing, guys. This is the last concept, and then we got one more example, and then we'll be done for the day, okay? So hang tight. Last concept, and this is, unfortunately, this is the hardest thing, and it's not really that hard. This is the formula for arc length. Now, I'm going to tell you right now, it's related to what we just looked at. Both of these things were circumference formulas, right? The circumference of a circle is 2 pi r, or pi times diameter, correct? So if I want to know just the length of this arc AD, well, that's not the whole circle. That's just a fraction of the circle. So basically what you've got to do is you just got to do that fraction of the circle times the circumference. So let me give you an easy example. let's say that in this example that the radius was, and just to keep it super simple, let's just say the radius was 2. And then let's say that the measure of angle AOB was, I don't know, let's keep it super simple. Let's just say it's 100. I have no idea. I'm making up numbers, okay? And I want to know what's the measure of the arc AB. Here's what the formula tells us to do. I'm sorry, I should not have used this. This should not be measure. This should be length. Measure is an angle measure. This should be length. I want to know the length of arc AB. Just use this formula. And I'm going to use this one. What is the measure of arc AB? Well, the measure of arc AB is 100, isn't it? So put 100 over 360, and then I got to do times 2, and then I got to times pi, and then I got to times the radius. What's the radius? Well, the radius is 2. So now, with our calculator, we just plug all that stuff in. So I'm going to do 100 divided by 360 and get whatever that is. And then I'm going to take that times 2 times pi, and then times 2 again, and I get 3.49. That would be the distance of that arc, that length of that arc. Yeah. You have pi on yours? Yeah, let me see. Usually there's a pi button. I do not see a pi button. Okay, sorry. All right, so let me tell you, if you do not have pi, you do not have a pi button, I recommend that you use this number. This is the number I would recommend that you use for pi. And I know it's more than the 3.14. I like you to be a little bit more accurate. Normally when I round things, I like to go out to at least 2 decimal places. So that's why I want you to use 5 decimal places. So you might want to add that to your notes. Most calculators these days, there's a pi button, and my guess is, and I'll work with you in a minute, that your calculator probably has a pi button too, but I'll have to figure that out in a minute. All right, so let's not do all of these. Let's just do, I want you guys to do this one right here. I want you guys to find the answer to B, which is find the red arc. In other words, I want to know what is the length of arc X, P, Y. That's what I want to know. I'm going to give you a minute. I'd like you to try to figure it out. I want to know the measure of arc X, P, Y, this red arc. Now notice it says leave your answer in terms of pi. We'll do both. I don't care. You can just multiply it all the way out like I did. I'll do a pi answer as well. So see if you can figure that out. You're going to use these formulas right here. In fact, let me kind of erase this. You're going to use these formulas right here to get this answer. I'm going to give you 2 minutes to figure that out, and then we'll be done for the day. Virtual students, I just sent you a link or a chat with the exit slip for the day. I'd like you to fill that out before you leave. We'll get this final answer. I think it looks like Ishmael maybe we can answer it. Oh no, that was probably previous problem. 30 seconds. If you're a virtual student and you want to throw that answer in the chat, that'd be cool. Just 2 decimal places of accuracy would be good. Alex, you got an answer?
65.45.
That's exactly what I got. Oops. You should get 65.45, and then let's go ahead and put the units on there, which is centimeters. That's exactly right, Alex. Good job. In case you did not get that, here's how you would work it. The length of arc XPY is equal to 250 divided by 360 times 2 times, I'm trying to make time symbols, those look like degree symbols, times pi times, and then the radius here, and the radius I think we said was 15. So this is how you would do it. In fact, let me get rid of those degree symbols here. We don't need those. And then this is how you'll get to this answer. Guys, that's all I've got for you today. Thank you for jumping in there when I kind of started leaning on you. I appreciate that. I hate to be that guy that has to, kind of be firm and all that, but I need you guys to participate. Please don't forget that next week is the last week before spring break. Today is the end of the 9 weeks, so if you have any missing work, that's due today. And then next week we do have a test on Chapter 8. I already have a review on Canvas for you. We'll review some on Thursday. The test will be on Friday. So let's get into that fourth quarter with a good score on that test on Chapter 8. Chapter 8 will cover sections 8.1 up through section 8.4. That's all I've got for you. I'll stay on here if you have questions.